Okay. All right. Example 6. It says, let g of x be a continuous function. Selected values are given in the table below. For which value of k will the equation g of x equal 3/4 have at least two solutions on the closed interval? All right. So here's what they're saying. Okay. So if you're traveling along here, here's where the action is. So I don't really, not too concerned about that. Not too concerned about that. I'm really concerned right here. All right. As I'm traveling from 3 to 5, x equals 3 to x equals 5, we've gone from 4 to 5. Okay. So the only way the intermediate value theorem is going to come in and have 3/4 have at least two solutions is if this value of k dips below 3/4. Let me show you what I'm talking about. So say we're traveling here. All right, so we got 3 and 5. 1, 2, 3, 4, 5. All right, so at 3 we're at 4. 1, 2, 3, 4. All right, and then at 5 we're at 5. All right, so we're here. Okay, so the thing is, the only way, so if it came down, and I'm looking at answer B right now, if it came down and it hit at 3/4, and I saw that happened at this moment, then I'm not guaranteed that it would have done that twice. Okay, it could, like we said before, it could dip below, hit that, do some stuff, and come back, but we don't know that. All right, so all I know is though, if you go below 3/4, right, then it had to hit 3/4 on the way down at least one time, and it had to hit 3/4 on the way back up. Okay, well, so that's out. It's got to be lower than 3/4. It's got to be lower than 3/4. That's not lower. That's 1.5. And so this is definitely lower than 3/4 because 3/4 would be like 12/16. If you thought about it with that denominator. Okay, so it is C. All right, now on 7, we have a function here. It's a piecewise function. When x is 5, you use x minus 3 squared. That's really weird. That's just a single point. So in other words, they could have just said this. F of x, all right, is equal to, what is it? 5 minus 3 is squared, which is 4, right? 5 minus 3 is 2, is 4. It's 4 when x is equal to 5. And then it's 6 when after that, no, back. It's 6 the rest of the time that it exists. Okay, so all the way up to 10. All right, so here's what we've got. We've got a weird looking function right here. It looks like the whole thing begins at 5. All right, so at 5, 1, 2, 3, 4. At 5, we're at 4. 1, 2, 3, 4. We got one single point. One single point right there. And then the rest of the time, it's 6. So 5, 6 here, all the way up to 10. Okay, and that's supposed to be flat. Okay, there we go. This is it. That's the function we're talking about. All right, and so it says find f of 5. Okay, well, we did that. So we'll go ahead and say it. F of 5 is equal to 4. Then it says and f of 10. Well, f of 10 is equal to 6 because it's 6 the rest of the time. All right. Does the intermediate value guarantee a y value such that f of 5, f of k is in between those two? Now, look, if you look at the graph, we only have the two values. We've got 4, we got 6, that's it. All right. So we got 4, we got 6. So it's asking, will I have something in between? Well, no. And the problem is it's not continuous, right? I mean, it's not. You've got this one point that it jumps and then it's continuous the rest of the way. But see, this is a unique one because it's not continuous at the beginning of the interval, and it must be. All right. So the answer is no. And the reason is intermediate value theorem does not apply. Due to, which I tried to put as one word, due to f of x not being continuous on the interval, and it's got to be closed interval. All right, 5 to 10. And the only place it messes up is at the very beginning, but it's enough to make a huge mess as far as the intermediate value theorem goes. Okay. It's enough to make a big mess because it just went 1 point, boom, and just skipped everything else and went. And that lack of continuity is what caused it.